So let's get started with the n queens problem, and first we'll understand the problem well, and then we'll go ahead and code the backtracking solution. So let's go ahead and create this CPP file, and once we are done, let's just close this down and get started with the n queens problem. So what we're going to do is first understand the problem correctly and then go ahead and code everything out. So let's first start by understanding the problem, and we'll create this comment here, this comment like this, and here we'll discuss what a chessboard looks like. For our example, let's just assume that our chessboard looks like this. Let's say we have a 4x4 chessboard. A normal chessboard looks like an 8x8, but let's say we can have an n×n chessboard, and this is the chessboard in which the first tile is black, the next is white, and so on. So what you want to do is keep queens here. We'll represent a queen using a hash. So let's say we keep a queen here. Where can we keep a queen now? Can we keep it here? No, because this queen can attack here. Can we keep a queen here? No, because this queen can attack here as well. Can we keep a queen here? Well, yes, we can. Okay, let's keep a queen here. Now we want to keep another queen in the next row. Notice that we cannot keep the queen in the same row. So let's go ahead and keep the next queen. So let's see, can we keep a queen here? No. 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 So since we cannot keep a queen anywhere, why can we not keep here? Because of the first queen. Why can we not keep here? Because of the second queen, and second queen. We cannot keep the queen here. So since we cannot keep the queen here, we did something wrong in the previous step. So let's go back and remove this queen, and let's also highlight where all this queen can attack. So this queen can actually attack here, and also here, here, and here. These are all the places that this queen can attack. Now where can we keep? We have checked this position is not allowed, so let's just mark this with a 0. And now we have to keep a queen here. Let's keep a queen here. Then let's see where now we cannot keep a queen. So you cannot keep it here, you cannot keep it here, you cannot keep it here, you cannot keep it in this whole row now, right? That is natural. And then you cannot keep it across this diagonal. Cool. So let's just go ahead and see where we can keep a queen. Can we keep a queen here? No. Yes. So let's just keep a queen here now. Okay, now let's just update all of this. So yeah, we cannot keep a queen here, and we cannot keep it here, and I think that's all. So in this configuration as well, let's just see where we can keep the queen now. So is there a configuration here where I can actually keep the queen? Well, seems like there isn't. Why? Because all of these positions are being attacked by one queen or the other. So in this case we couldn't find the perfect configuration. So let's just go back one step. So what we'll do is remove this one and see, can we do something about this? No, we cannot. So let's just go back another step. Can we do something about this? Well, let's just reset the key, reset our chessboard. So let's just go with this chessboard right here, and let's just see. So this position can actually not be a queen. What do? We keep the queen here. Now let's see what all positions are covered. This position is covered, this position is covered, this is covered, this is covered, this is covered, and this is covered. Now let's try to keep the next queen. Can we keep the queen here? Well, yes, we can keep the queen here. Now let's just see what all positions are changed. Well, this position is changed, this position is changed, this position is changed, and I think that's all. Now let's keep a queen. Can we keep the queen here? Let's just keep it then. Okay, so yeah, here we will get 3, rest all is almost same. And can we keep the queen here? Yes, we can. We have found a perfect configuration for the queens so that they do not attack each other. So this is one of the configurations in which these queens are not attacking each other. How do we find this configuration? What are the steps we followed in this case? So let's just go ahead and understand our thinking before we go ahead and code this one. Alright. So what was the thinking that we used? So 1. Keep a queen at non-forbidden position. Make its neighbors forbidden. Okay. And then third, we need to see if there are no choices, then we need to do this paragym known as backtracking. So we need to backtrack. Backtracking means you have taken a wrong step. So let's write down what it means. You have taken a wrong step, so mark that step as wrong and go ahead. How can you understand backtracking? You can understand backtracking like a maze. You do not know how the maze ends, but you have let's say 4 options, 4 different caves that you can go into this maze, and you go into one of the caves and realize that this is not the right cave. Then you backtrack, come along your footsteps. Okay, so you just come back and say, I will never go into the first cave again because this is not the exit. So you go into the second cave. If you find the exit, okay, else mark this as wrong as well. Go to the next cave, see if this is right. If this is not, then cross it off. Then so on with all the cases. This is known as backtracking, and this is the approach that we are going to use here. And the thing is, since all of these sub problems are very similar, the thing that is going to be used here is also recursion. So let's see why recursion is applicable here. Why is problem reducing? Okay, so let's see why is the problem reducing. Because we are keeping a queen every time. So either we can keep the queen and go to less number of queens, that way the problem is reducing, or we cannot keep the queen at all and we can report that there is no solution here. So either in the caves you are moving towards the exit, or you are saying go back to the previous position. Why? Because there is no solution here. That sounds good. And in the next video we'll see how to code this one. I hope you have understood n queens problem. I hope you have understood how we will approach it. It is the most basic and the way that you do on an actual chessboard. So it is the most basic way you can think of, but you have to keep that in mind. I hope you have understood it, and I'll see you in the next video.